All right, so today's notes are all about this idea called the median and the altitude of triangles. So the median of a triangle is our segment from a vertex to the midpoint. So this is where our midpoints come in handy. We need to know exactly where they are. Three medians are concurrent, and the point of concurrency is now called the centroid. So notice the three different lines we've talked about, perpendicular bisectors, angle bisectors, and medians, all have different points of concurrency. They're all called something different. And the median is called the centroid. Now there is a centroid theorem that will help us find the lengths of things. And the most important part about that is right here. The medians of triangle ABC, would help if I could draw a straight line, meet at point P, and AP is 2/3 of AE, okay? BP is 2/3 of BF, and CP is 2/3 of CD. So what that means is, I don't know if I can zoom in with this particular, oh, well, I can move those, that's pretty cool, but I can't move the slide, I can't zoom in on the slide, so we'll try our hardest. What this means is that this length right here, AP, is 2/3 of the total length, okay? AP is 2/3 of the total length, which means EP is 1/3 of the total length, okay? So we have this 2/3, and this is 1/3, because the whole length is cut up into thirds, okay? And it's the same for this little side, that little side. All those green sides are all going to be 1/3, and all the blue sides are going to be 2/3. Okay? So in triangle RST, point Q is the centroid, and SQ is 8. Okay? So if SQ is 8, find QW and SW. So that means they're asking me, well, first let's see what we know. I know the blue side of the triangle, okay, or the blue line of the triangle. I know the 2/3, which means they're asking me to find QW, which is 1/3. And then SW is the whole thing. So the whole length. Okay? So I don't know if I'm going to do this significantly more complicated than normal, but let's give it a shot. If SQ is 8, and I know that it's 2/3 of the length, I know that 2/3 is going to equal 8. So my goal is to find 1/3, or the whole length. And I think, because I haven't had my coffee yet, that we can do 3 times 8 divided by 2. Nope, that's not going to work. Just being honest, not going to work today. That would mean that 1/3. So 1/3 is going to be, I really overthought that problem. I'm so sorry. I'm 100% confused a lot of you. I know I did. If 8 is 2/3, 1/3 is going to be 4. Okay, so that means that QW is going to equal 4. Okay, now Ms. Stark, how'd you get that? Well, 2/3 means there's 2 of them, and half of 8 is 4. So if I got 2/3, then I have 4 plus 4, which is 8. So 1/3 has to be 4, which means the whole length, SW, so if I do this, it's going to equal 8 plus 4, which is 12. Take me all the way to... Okay, in RST, point Q is the centroid, which means, guys, if I see centroid, that screams median. Centroid screams median. Okay, SQ is 12. Find QW and SW. So remember, SQ, by definition, is 2/3. Which means I need to find 1/3 of 12. And just as a reminder, of means to multiply. 1/3 of 12. Nope. Wow, guys, my coffee really isn't kicking in today. I'm so sorry. We're gonna go, if 2/3 is 12, then 1/3 has to be 6. So that means QW, that green part, QW, which is 1/3, has to be 6. Completely different slides, it's fine. QW has to be 6. SW, the whole thing, has to be 12 plus 6, which is 18. Okay? All right, ladies and gentlemen, let's go ahead and look at this one. In triangle JKL, ZW is 7. So I'm going to try and write that in there. 7. LX is 8.1. Find KW. Okay, so they want me to find that whole length. Huh. Well, ZW, LX, they want KW, the whole length. So ladies and gentlemen, I feel like this problem has a lot of extra information in it that we don't actually need. Because if by definition from the centroid, so by definition, the centroid is 1/3, that's a 2, 1/3 distance to the midpoint. And I know that ZW is 7. That means that ZW is 1/3. If I want to know the whole length, that means that I'm just going to take 7 times 3. So KW is 21. That LX there, I'm fairly certain was just there to confuse us. Okay. The altitude of a triangle is the perpendicular segment from the vertex to the opposite side of the line. So we're going straight down. A key to this with an altitude is the fact that it is perpendicular. Okay, so it's perpendicular segment by definition means it creates a 90-degree angle. Okay, so we're going to take a vertex and we're going to go straight down to the other side. Notice in this picture that our altitude can be inside the triangle or it can be outside the triangle, and that's 100% okay. The point, if we were to draw all the altitudes into inside the triangle, they would meet at a point called the orthocenter. Okay, so that's where the altitudes meet. Okay, notice that this orthocenter meets inside the circle. Sometimes they will meet inside the circle, sometimes they won't. Okay, depends on what type of triangle you're given and what you have. All right, and this last slide here is for you. I would copy this into your notes like crazy. I would, or print it out and tape it or something. But notice that over here along the sides, I've given you every type of line that we've talked about within a triangle. And then the best part is I've told you their points of concurrency. Okay, what are they called? Because every single one has a different point. Okay, and then I've given you examples and different properties of them. Okay, and that will come in handy the more you keep going and trying to solve some of these problems. Okay, so if you have any questions, let me know, but these were your notes.